In this video, I'll help you unlock the math skill area of triangles and parallelograms. Without understanding this, area questions often feel confusing, even when you know the formula. I'm going to show you 3 simple keys, which are the exact pieces of information you need to make this skill feel easy to learn. I refined these keys over 10 years of teaching, and they're the exact insights most students never get shown. In this section, you will learn where this skill is used in the real world. Imagine you're tiling this outdoor space. Some tiles fit perfectly, but others, they've been cut at angles. You start noticing 2 shapes appear again and again: triangles and slanted rectangles, called parallelograms. Now here's the problem. You already know how to find the area of a rectangle. Area equals base times height. Easy. But these shapes are not rectangles. So what do? Do you still multiply the sides? Does the angle change the area? Or do you need a completely new method? And here's what makes it interesting. These 2 shapes look completely different. One has 3 sides, one is slanted. However, there is something very surprising about these shapes. They're actually connected to something you already know. In the next key, you're going to take these shapes and uncover the connection. In this section, you will learn the formula used to find the area of a triangle. Let's start with a right-angled triangle. Remember, when we find area, we're counting the squares inside a shape. But triangles are different. The squares inside them don't fit neatly. They're cut. So instead of counting, let's use something we already know. What's the area of a rectangle? Yes, base times height. But this isn't a rectangle. So how can we still use that idea? Let's imagine building a rectangle around the triangle, using the same base and the same height. Now here's the key question. How much of the rectangle does the triangle take up? If we take the original triangle, make it an exact copy, rotate it, and place the identical triangle next to the original, it completes the rectangle perfectly. So 2 triangles make 1 rectangle, which means 1 triangle must be half of a rectangle. So instead of base times height, the formula is the area of a triangle equals half times base times height. Now you might be thinking, does this only work for right-angled triangles? Let's see. Trace a rectangle around the triangle like this. Next, we notice we have 2 missing pieces. When the perpendicular height of the triangle is labelled, it creates 2 smaller triangles inside the original triangle. If we copy triangle 1, then rotate it and slide it into this missing space, it fits. Now let's copy triangle 2. Again, let's rotate, slide it into this space, it fits perfectly. So the rule works for every triangle. Here's where students often go wrong. They use the slanted height as the height. But that's not correct. The height must be perpendicular to the base. So your key tip is, look for the right angle. In this section, you will learn the formula used to find the area of a parallelogram. Let's look at this parallelogram. You're given the base and the perpendicular height. But this shape is slanted. So do we need a new formula? Or is it connected to something we already know? Let's imagine drawing a rectangle around it. Using the same base and the same height, now look closely. There's a small triangle on one side that doesn't fit. If we cut that triangle out and slide it across, it fits perfectly on the other side. And just like that, the parallelogram becomes a rectangle. The shape changed, but the area didn't. So the formula is area equals base times the perpendicular height. You now know all the key information on this concept. However, can you solve all exam style questions? Watch this next video to master questions easily.